Today we are going to see about power, energy and power factor in AC electrical circuit. See, power. What is power? Power means it is a rate of energy consumed in an electrical circuit. See, the unit of power is watts. Formula for power in AC circuit is P is equal to VI cos theta. There are three different powers in AC circuit. First one is real power, next one is reactive power and the last one is apparent power. Real power means it is the power that is used to do work on the load. The unit of real power is Vrms Irms into cos theta. See here, the RMS refers the root mean square value. That means, see, in electrical circuit, the electrical components are continuously varying components. It is not a stable one. It varies with respect to time. Figure shows the electrical components diagram. See, at time t is equal to 0, its value, it may be voltage or current, its value is 0. At time t is equal to b, its value is maximum. That is, it reaches its maximum value. That value is called peak value. At time t is equal to c, it will be 0. And again it increases negatively and so on. So, we cannot take any particular point as a voltage or current value. So, we go for the RMS value. So, we can easily find the RMS value from the peak value. Vrms or Irms is equal to 0.707 into V peak or I peak. Peak value is the maximum value of an electrical quantity during one complete cycle. The unit of real power is kilowatts. Next one is reactive power. There are three types of loads in electrical circuit, which are the resistive load, the inductive load and the capacitive load. The capacitive loads are always generates the reactive power, and the inductive loads are always consume the reactive power. The resultant of these two power dissipates on the reactive load, that gives the reactive power. Okay. The inductive and capacitive loads are always called reactive loads. The power from that is called the reactive power. The unit of the reactive power is kVAr, and the formula for calculating the reactive power is Vrms into Irms into sin theta. Next one is apparent power. The combination of these two power gives the apparent power. The unit of the apparent power is kVA. See, next one is the power triangle. It is a combination of the real power, reactive power and apparent power. It is a right angle triangle which is having the real power and reactive power are taken as the adjacent side and opposite side of this triangle. The hypotenuse shows the apparent power of the circuit. Next is the energy of the circuit. Energy means the product of the power into time. Its unit is kilowatt hour. Normally, the power is measured by an energy meter. The circuit diagram to measure the energy of a circuit is shown in figure. Power in RLC series circuit. Series circuit means the resistance, inductance and capacitance are connected in series. Here, we know in series circuit, the current through the circuit is always same, but the voltage across each element is different. So, we can calculate the voltage V1 that is the voltage across the resistor, and V2 be the voltage across the inductor, and V3 be the voltage across the capacitor. See, we know the formula for finding the power on a circuit, that is P is equal to VI cos theta. V be the voltage and I be the current through the circuit, and cos theta be the power factor of the circuit. Now, we are going to find the power factor of the circuit. Cos theta is equal to R by Z. Z is equal to root of R square plus XL difference XC. Here the XL be the inductive reactance and XC be the capacitive reactant. Suppose in a circuit, if XC is greater than XL, then the circuit is having a power factor of leading power factor. Suppose if XL is a greater value, the circuit is called inductive circuit. That means the power factor is lagging power factor. Then now we find the XL value. XL is equal to 2 pi f into L. We know the L value, then we can easily find the XL. Next find the XC, that is equal to 1 by 2 pi f into C. From C we can easily calculate the XC. Then Z we can easily calculate. Next is power. Power is equal to VI cos theta. From cos theta, current and voltage, we can calculate the power value. Next is the power in AC parallel circuit. In parallel circuit, all the elements are connected across the supply. Here the voltage is same, but the current is different. See, let us consider V be the voltage of a given circuit. Here all the elements R, L and C are connected in parallel. Then we can calculate the current of a circuit. Here the current through the resistor is I1 and current through the inductor is I2 and current through the capacitor is I3. Now we can calculate the total current I, which is equal to I1 plus I2 plus I3. Then we are going to calculating the cos theta, that is equal to R by Z. We know the value of Z, that is the formula is Z is equal to root of R square plus XL difference XC. Then find the power. Power P is equal to VI cos theta. So all the known values we can easily calculate the power. Now we are going to calculate the vector diagram of the given circuit. See, here V be the voltage of the given circuit. This can be taken as the reference vector. See, here we have three components. One is resistance, next one is inductance, and the last one is capacitance. The current through the resistance is always in phase with the voltage. So the vector is drawn over that reference line vector, that is V. So next is the current through the inductor IL. So it always lags behind the voltage, reference voltage V. So it is drawn 90-degree lags on the reference voltage V. Next is the current through the capacitor. It always leads the reference voltage by an angle of 90-degree. So it is away from the inductor current, opposite direction of the inductive current. So the resultant of the current I1 and I2 minus I3 be the total current IT. Here we have one more quantity in the vector diagram, that is I2 minus I3. That is the difference between the current through the inductor and the current through the capacitor. Students, I hope that you all have enjoyed the class so far, and see you in the next class. Thank you.